Good day, Math 6 learners! Welcome back to our last episode in Mathematics 6. Again, I am teacher Estrella Saison Palar, your Math 6 helper. I am here to help you understand your math lesson well. Let's learn together! Mathematics 6, your fantastic subject! Please be ready with your pen, paper, and self-learning module. And let's learn more interesting and challenging lesson today. The last lesson in Mathematics 6 Quarter 4 Week 8 is solving routine and non-routine problems involving theoretical probability. Our learning competency is to solve routine and non-routine problems involving theoretical probability. In this lesson, you are expected to solve routine and non-routine problems involving theoretical probability. Let's have a review of our previous lesson, solving routine and non-routine problems involving experimental probability. What are the steps in solving routine and non-routine problems involving experimental probability? Can you give the steps? Yes. The steps in solving routine and non-routine problems involving experimental probability are the following. First, understand what is asked and what are the given facts. Second, plan what strategy to use to solve the problem. Third, solve. Solve using the experimental probability formula. Experimental probability is equal to the number of times favorable outcomes occur over the number of trials in the experiment. That's right! Congratulations! Discuss the last lesson of Quarter 4, Module 8, solving routine and non-routine problem involving theoretical probability. Let's find out what is theoretical probability of an event and other terms used in this lesson. Theoretical probability of an event is the number of ways that an event can occur divided by the total number of possible outcomes. Favorable outcome. Favorable outcome is the outcome you are looking for in an experiment. Possible outcome. Possible outcome is any possible result in an experiment. This is the formula in finding theoretical probability of an event. Theoretical probability of an event is equal to the number of favorable outcomes over the number of possible outcomes. For example, number 1. A box contains 6 triangles, 14 squares, and 4 circles. Find the theoretical probability of getting a triangle. We will use the following steps in solving routine and non-routine problem involving theoretical probability. So step number 1, understand what is asked and what are the given facts. Step number 2, plan what strategy can we use to solve the problem. Step number 3, solve. Solve using the theoretical probability formula. Following all the steps, we can answer now the given example. For step number 1, understand what is asked. The answer is the theoretical probability of getting a triangle. Next, what are the given facts? We have 6 triangles, 14 squares, and 4 circles. The next step, plan what strategy can we use to solve the problem. We will use theoretical probability formula. The third step, solve. So there are 6 triangles, so therefore, the number of favorable outcomes is 6. The total number of possible outcomes is 24 because we have 6 plus 14 plus 4, so we have 24. We will use theoretical probability formula in solving the problem. Theoretical probability of a triangle is equal to the number of favorable outcomes over the number of possible outcomes. So we have the probability of a triangle is equal to 6 over 24. The next, we have to simplify. Divide both 6 and 24 by their GCF, which is 6. So 6 divided by 6 is equal to 1, and 24 divided by 6 is equal to 4. So the P triangle is equal to 1 over 4. So the answer is the probability of getting a triangle is 1 over 4. Another example, example number 2. The manager of Great Adventure Amusement Park took a random survey of 100 visitors to the park. This summarizes the result in the following table. We have the age and the number of visitors. 3 to 11 years old, we have 23 visitors. 12 to 20 years old, we have 35 visitors. 21 to 40 years old, we have 26 visitors. 41 above, we have 16 visitors. A crowd of 5,000 visitors is expected at Great Adventure over the weekend. Predict how many of these visitors will be under 21 years of age. Let us solve using the steps. First, understand. What is asked? The answer is the number of visitors will be under 21 years of age. Next, what are the given facts? We have 23 visitors aged 3 to 11 years old, 35 visitors aged 12 to 20 years old, 26 visitors aged 21 to 40 years old, and 16 visitors aged 41 years old and above. The next step, we have to plan. What strategy can we use to solve the problem? We will use theoretical probability formula. To solve this problem, we have the total number of visitors surveyed. We have 23 plus 35 plus 26 plus 16 is equal to 100. Then the total number of visitors under 21 years of age, we have 23 plus 35 is equal to 58. Using the theoretical probability formula, so we have theoretical probability is equal to the number of favorable outcomes, which is 58, over the number of possible outcomes, which is 100. Next, we have to simplify. Divide both 58 and 100 by their GCF, which is 2. So 58 divided by 2 is equal to 29. 100 divided by 2 is equal to 50. So the probability under 21 years old, we have 29 over 50. The next step, we have to multiply the probability by the number of expected visitors. We know that there are 5,000 expected visitors at the Great Adventure over the weekend. So we have 29 over 50 multiplied by 5,000. But before multiplying, we can simplify 50 and 5,000. So we have the GCF is 50. So 50 divided by 50 is equal to 1. 5,000 divided by 50, we have 100. So we can proceed now to multiplication. So we have 29 multiplied with 100, we have 2,900. So the answer is, the Great Adventure can expect 2,900 visitors to be under 21 years old. Can you recall the steps in solving routine and non-routine problems involving experimental probability? The steps are: number 1, understand what is asked and what are the given facts. Number 2, plan what strategy to use in solving the problem. Number 3, solve using the experimental probability. Experimental probability is equal to the number of times favorable outcomes occur over the number of trials in the experiment. This time you're going to answer what's more in your self-learning module. You follow the given direction. Direction: read and answer the problem below. Write your answer on your answer sheets. I will give you 2 minutes to answer. In a class of 40 pupils, 28 are in the drama club and 12 are in the art club. If a pupil is selected at random, what is the probability that the selected pupils is in the art club? Let's answer the problem together. A. What is asked? The answer is the probability that the selected pupils is in the art club. Next, B. What are the given facts? The answer is the class of 40 where 28 are in the drama club and 12 are in the art club. The next is we have to solve. Solve using the theoretical probability formula. So we have to find the probability of pupils in the art club. So the probability of pupils in the art club is equal to the number of favorable outcomes over the number of possible outcomes. So the probability of pupils in the art club is equal to 12 over 40. The next is we need to simplify your answer. So the probability of pupils in the art club is equal to 12 over 40. We can simplify by dividing both 12 and 40 by their GCF, which is 4. So 12 divided by 4 is equal to 3. 40 divided by 4 is equal to 10. The next is we have to simplify 3 over 10 by 40, which is the total number of pupils in the class. But before multiplying, we can simplify both 10 and 40 by their GCF, which is 10. So 10 divided by 10, that is equal to 1. 40 divided by 10 is equal to 4. So we can now proceed to multiplication. So 3 times 4 is equal to 12. And 1 for 10, that is, so 12 over 1, or that is equal to 12. So the probability of pupils in the art club is equal to 12. Again, the answer is, the probability that the selected pupils is in the art club is 12. Congratulations, math learners! You answered it perfectly. At this moment, you answer assessment on your self-learning module. Direction: read each item carefully. Choose the letter of the correct answer and write it on your answer sheet. For number 1, 2, 3, please refer the data given below. For item 1, 2, 3, there are 5 red balls and 6 blue balls in a jar. What is the probability of picking a red ball? Again, for item 1, 2, 3, there are 5 red balls and 6 blue balls in a jar. What is the probability of picking a red ball? Number 1 question, what is asked in the problem? A, the number of red balls. B, the probability of picking a red ball. C, the probability of picking a blue ball. D, the number of blue balls. Again, for number 1, what is asked in the problem? A, the number of red balls. B, the probability of picking a red ball. C, the probability of picking a blue ball. D, the number of blue balls. Timer starts now. Time is up. The correct answer is letter B, the probability of picking a red ball. Next, number 2. What are given? A, 5 red balls. B, 6 blue balls. C, red and blue balls. D, 5 red balls and 6 blue balls. Again, for number 2, what are given? A, 5 red balls. B, 6 blue balls. C, red and blue balls. D, 5 red balls and 6 blue balls. Timer starts now. Time is up. The correct answer is letter D, 5 red balls and 6 blue balls. Next, number 3. What is the answer? A, 40%. B, 45%. C, 50%. D, 55%. Again, number 3. What is the answer? A, 40%. B, 45%. C, 50%. D, 55%. Timer starts now. Time is up. The correct answer is letter B, 45%. Next, number 4. A spinner has 5 sectors, namely red, blue, orange, yellow, and black. If you spin once, what is the probability that the spinner will land on color white? A, 0%. B, 25%. C, 50%. D, 75%. Again, for number 4, a spinner has 5 sectors, namely red, blue, orange, yellow, and black. If you spin once, what is the probability that the spinner will land on color white? A, 0%. B, 25%. C, 50%. D, 75%. Timer starts now. Time is up. The correct answer is letter A, 0%. Next, for item number 5 to 6. You ask a friend to think of a number from 3 to 10. What is the probability that his number will be 6? Again, for item number 5 to 6, you ask a friend to think of a number from 3 to 10. What is the probability that his number will be 6? Number 5 question. What is the total possible outcomes? A, 10. B, 6. C, 8. D, 3. Again, for number 5. What is the total possible outcomes? A, 10, B, 6, C, 8, D, 3. Timer starts now. Time is up. The correct answer is letter C, 8. Next, number 6. What is the answer? A, 1 over 8, B, 2 over 8, C, 3 over 8, D, 4 over 8. Again, number 6. What is the answer? A, 1 over 8, B, 2 over 8, C, 3 over 8, D, 4 over 8. Timer starts now. Time is up. The correct answer is letter A, 1 over 8. Next, number 7. The rules of a contest say that there is a 6% chance of winning a prize. 400 people enter the contest. Predict how many people will win a prize. A, 22, B, 6, C, 24, D, 240. Again, for number 7, the rules of a contest say that there is a 6% chance of winning a prize. 400 people enter the contest. Predict how many people will win a prize. A, 22, B, 6, C, 24, D, 240. Timer starts now. Time is up. The correct answer is letter C, 24. Next, number 8. There are 15 6th graders, 10 7th graders, and 16th 8th graders in a gym class. The gym teacher randomly selects one student to collect balls. What is the probability of choosing not a 7th grader? A, 10 ways, B, 31 ways, C, 26 ways, D, 41 ways. Again, for number 8, there are 15 6th graders, 10th 7th graders, and 16th 8th graders in a gym class. The gym teacher randomly selects one student to collect balls. What is the probability of choosing not a 7th grader? A, 10 ways, B, 31 ways, C, 26 ways, D, 41 ways. Timer starts now. Time is up. The correct answer is letter B, 31 ways. Next, number 9. A bag contains 12 red marbles, 8 blue marbles, and 4 yellow marbles. Find the theoretical probability of getting a blue marble. A, 3 over 3, B, 2 over 3, C, 1 over 3, D, 3 over 4. Again, number 9. A bag contains 12 red marbles, 8 blue marbles, and 4 yellow marbles. Find the theoretical probability of getting a blue marble. A, 3 over 3, B, 2 over 3, C, 1 over 3, D, 3 over 4. Timer starts now. Time is up. The correct answer is letter C, 1 over 3. Next, the last number, number 10. A medical study tests a new medicine on 4,800 participants. It is effective for 4,200 participants. Find the experimental probability that the medicine is effective. A, 78 and 5%, B, 87 and 5%, C, 97 and 5%, D, 98 and 5%. Again, for number 10, a medical study tests a new medicine on 4,800 participants. It is effective for 4,200 participants. Find the experimental probability that the medicine is effective. A, 78 and 5%, B, 87 and 5%, C, 97 and 5%, D, 98 and 5%. Timer starts now. Time is up. The correct answer is letter B, 87 and 5%. Now try to count all your correct answers. Did you make it perfectly or not? If not, do not worry. Maybe next time you will make it. Just bear in your mind, scores are only numbers. What matters most is how much you learn in your math lesson. So for your great performance today, congratulations! If you still need some training about the lesson, the DEPED Commons and the DEPED TV official YouTube channel are there with your self-learning module to develop more your mathematical skills. Always remember that mathematics does not make simple things complicated, but it makes complicated things simple. With that, this is your math helper, teacher Islia Saison Palar, saying to you, in mathematics never say I can't, always say I'll try. Thank you and goodbye!